Okay, class. So today I want to go over a homework assignment that I recently gave y'all. And it was a word problem that we have here displayed on the left, which was John had 12 gumballs. He eats some of them. If he can only eat 5 at most in one day, how many would he have left after one day? The word problem asks you to represent this problem as many ways as you can. So first I want to go over some misconceptions/mistakes that I saw in the entire class. And that was that there was a little bit of a misunderstanding of what the equal sign means. And I want to go over that today in our lesson. And then another one was that there was a struggle with the relationships between the quantities and the word problems. And this means that you guys, also some of us were struggling with reading the word problem and figuring out the different variables that we would need to use to set up an equation. I just want to kind of go over individually some problems that I saw in each of y'all's work. And so that's going to be Kathy. I saw that you gave the correct answer, and you could just use a little bit review with showing other representations because the problem does ask for you to review them as many ways as you can. Ralph gave the wrong answer, but he could benefit from reviewing being introduced to other representations that could help him visualize and conceptualize the information better. Diane gave the wrong answer, and I feel like it's because she most likely doesn't understand what the equal sign means, and then she also has problems with taking out the variables from the word problem and setting up an equation. And she can benefit from an overall review of algebraic representations and expressions. And then lastly, John gave the correct answer, and he actually used a different model from his classmates, but he could use a little review over all of the representations. So I took all of these misconceptions and mistakes, and I'm going to build a lesson today for my class. So first let's start with Kathy. So Kathy, your work is being displayed on the board on the left here, and it shows that you did your work in the form of an equation. So can you please explain to the class how you found your solution? Can you please explain what each part of your equation represents? Awesome. So next we're going to move on to Ralph. And Ralph, we're going to display your work on the board right over here. And I see that you solved your problem in a very similar way to Kathy's. Can you explain to us how you solved your problem? Awesome. So class, Kathy and Ralph solved their problems by an equation being their representation. Can anyone spot the difference between Kathy's and Ralph's work? Let me see if I can put both up on the board here. There are different ways we could solve this problem, but they will all come up with the same solution. So it looks here that we have two different solutions. So we're going to see in a little bit which one was right, and we're going to move on to Diane. Diane, can you please help us explain how you set up this equation? We see that you kind of set it up similar to Ralph's and Kathy's, but it does have different variables in different places, and the equal sign is on the opposite side and such. So class, what I want you all to do is I want you to turn to your shoulder partner and tell them one thing that you notice that is different about Diane's equation compared to Kathy's and Ralph's. Great. Next, we're going to finish up with John. So John, I see you solved your problem with a different representation from your peers. Can you please explain it? As a class, I want to ask the question. Kathy and John both came out with the same answer. So they both came out with 7 gumballs as their answer, but they both used different representation models. So who was right? You're right, they both were. You can use different models to find the solution to a word problem. I'm going to help us review these concepts shown in our word problem by using a new type of model. I'm going to use the set model here, which is for the separate problem, which shows a start minus a change equals a result. So basically in this word problem, we know that they started with 12 gumballs, which is why we have our base 10 blocks of a rod of 10 that represents 10 and 2 units, which represents all together as 12, and then the change, which is when they eat 5 gumballs. So we have 5 units, which each represent 1. So what we're trying to find is the result. So in order to do that, we're going to need to subtract this 5 from this problem up here. But because we don't have 5 units, we're going to need to start by regrouping. So what I'm going to do here is I'm going to cross this out. I'm going to cross this out, and that makes it 10 units. So I can add 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now we have 10 units on this side. So we have 10 plus the 2 that we already had. So we have 1, 2. And we're going to need to get rid of 5, which is our change. So we can cross them out. So we can do 1, 2, 3, 4, 5. And that leaves us with our result, which our result is going to be 1, 2, 3, 4, 5, 6, 7. And so we could put our 7 over here. This is a type of model that we can use to be able to visually demonstrate what our equation is showing. So, like we can see here, it's a balance beam. So on the left here, we have, again, our start, minus our change equals our result. So this number over here, which is 7, has to equal the number over here in order for it to balance. And that is why we crossed out our change, which leaves our 7 in our start and then our 7 in our result. So this is another type of representation that we could have used to solve this problem. Another type of representation that we can use is a number line. A number line is a great thing that we can use to visualize what numbers are changing and what numbers are being subtracted or added. So what we have here is our equation of 12 gumballs, and then they eat 5, and we're trying to figure out how many are left over. So the first thing we're going to do on our number line is we're going to mark 12 because we're starting at 12 with the 12 gumballs. And then we're going to go back by 5 because we're subtracting them. So we're going to go back from 12 to 11, which is 1, 2, 3, 4, 5. So each jump represents losing 1 gumball. So between 12 and 11, we lose 1 gumball. Between 11 and 10, we lose another. And so on until we lose 5 gumballs. And that's where we'll end at how many gumballs we have left, which is 7. Okay, students, so the last model I want to show you is just a basic equation using base 10 blocks. So we can use base 10 blocks to represent our entire equation, but just with these fun little blocks. So can anyone tell me what they think this long one's going to be? We just discussed it. Can anyone remember what that name is? That's correct. It's called a rod, and a rod represents 10 units. And what a unit is these little squares over here, and each unit represents 1. So if we have 1 rod and 2 units, that means that we have 12 over here, and then we have 5 units, which is 5. So in our equation, we were trying to figure out if you started with 12 gumballs and ate 5 of them, how many would you end up with? So we can use these base 10 blocks to find that. So what we'd have to do is take away 5 units from over here, but we don't have 5 units, we only have 2. So what we're going to need to do is regroup, and we're going to regroup in base 10, which basically means we're just going to break up these blocks into 10 pieces. So we have our 10 pieces over here that I broke up for us into our 10 units, and then we're going to go ahead and add our 2 units that we already had. Okay, and then we're going to subtract our 5. So now that we have a total of 12 units minus 5 units, we can find how many we are left over with. So in order to do that, we're just going to go ahead and just take away or cross out 5 from the left, or 5. And then we're going to count how many we have left over. So we have 1, 2, 3, 4, 5, 6, 7. So that means we have left over with 7. So no matter which representation that we used, whether it be the scale for the set model or the number line, or even just using basic base 10 blocks, we can figure out what the answer is, which is 7. So I'm going to ask my class, can anyone tell me which one they liked the most here? Great. And I want everyone to turn to their shoulder partners and try to figure out if any of our examples that we saw on the board were similar to the new ones that we learned about. One thing that I noticed was that someone had one very similar to our base 10 model here. Instead of using base 10 blocks, John used circles, and that's something that we've learned before. So you can easily do that. And then another one that we used is a number line, and that's something new. Can anyone tell me what we used the number line again for?